Welcome to myprojectbazaar.com. Now we can going to discuss about the project impact of assessment of DG in distribution system from minimization of total real power losses viewpoint. Now we can going to discuss about the abstract of our project. First we can for distribution generation using that IEEE 14 bus system. In our IEEE 14 bus system are using different distribution generation and load generation we can using that. So and another thing we can consider that our voltage performance, if in case we can improve our voltage performance, we can improve our power and reactive power injections and everything will also improve that. So we can improve our one of the technology we can invent that least weighted least square method we can using that in this method. So we can improve our voltage magnitude and current angle will improve our entire line, and we can analysis of entire 14 bus systems of line and line load and line losses. We can consider this entire Newton Raphson power flow using that this our system of DG assessments we can using the reactive power losses. Next we can going to discuss about the flow diagram of a project. First we can see about the IEEE 14 bus system. So this is some different bus data we can generating the IEEEs for line load and bus load. Bus data are including that bus data and line data are in this block. So we can calling the some functions calling block using that. This call the functions using some load added the specific lines for this block. So the specific blocks is how much we can perform that this particular line. So we can analysis is passing to the PMU for weighted least square method. This can using that to place the different place in generator and find out the cost of the generator and marketing clearance and find out the resizing of the generation. So generally we can analysis of this block, focus on our voltage performance. Because of we can improve our voltage performance, everything we can improve that. Specifically we can reduce our losses, reactive power losses, and improve our real power improvements. So we can improve our this PMU of measurement we can using the this entire system. For voltage stabilization we can improve our systems. And another thing we can see about that, we can using the distributed generation. The distributed generation is optimal placements of our every bus systems. So which thing we can made as load, which thing we can demand response of the our system. So we entirely calculate of this flow diagram of the process. We can find out the clearance of this wave. Next we can going to discuss about the running process of our project. The proposed system implementation done in MATLAB version 2013A. The first to open the script MATLAB script file and create the MATLAB codes for entire IEEE 14 bus system generations. Because we can save us our line data and load data and the generation data. So whatever we can include that is the MATLAB script files and the different Newton Raphson functions and weight least square and agent phase data we can including this entire script files. So we can mainly running on main.rm file for run the MATLAB file. This is an executing my file of this is for bus data. We can for using the 14 bus system for 14 bus system data, so we can import that for visit bus we can using bus type with PV bus or PQ bus or PV bus water slack bus. So we can type 3 is on PQ bus, type 2 is on PV bus, and type 1 is on slack bus. So we can using that these different entire systems and for voltage in per units and angle in per units of different data, so we can importing that for real and reactive power generations and real power in load and reactive power in load. So we can find out the different data we can for IEEE 14 bus system. Everything we can getting calculate as percentage of tolerance and minimum or maximum we can getting that. Another thing we can see for line data. So this is one line data from to from bus and to bus, which bus to which where we can connecting the lines. So we can bus number to bus 2, so we can justify the our lines. So we can these lines, we can how much we can resistance and reactance and susceptance we can find out these values. So susceptance we can find out for this resistance and reactance, we can for susceptance inverse of resistance, so we can calculate susceptance values and the transformer ratios. Transformer taps and different number of transformer using that, and so number of taps means in case we can connect the two lines, so some things are tolerance value we can getting that, so the transformer taps also we can find out that these specific sections. So we can number of lines in 14 bus systems are nearly 20 lines are we can connecting the 14 bus system. Next, this is for our main major results for that. See, this is for first graph is an voltage angle estimation error without PMU, phasor measurement unit. Without phasor measurement unit we can find out the errors, how much we can error we can in the specific entire buses for a 14 bus system. These are some gradually and linear some variations. These are two for voltage and magnitude results. This is an voltage angle estimation error. This is an voltage magnitude estimation error. This is the two things are without PMU. So this is our difference for that. And again we can below the graph for 3 voltage angle estimation with the PMU. So we can entirely different that because of this entirely in per units and some gradually inverse to our peak over voltage and our real power generation voltage. Real power generation voltage means our data voltages. Some inversions to the degree will getting this wave. So similar that we can find out the voltage magnitude estimation with the PMU. So we can very percentage of error we can find out that some gradually goes to the zero of different bus systems. So we can difference of these two parameters. Next we can see about the MATLAB command window. Some results are displayed as MATLAB command window for Newton-Raphson power flow analysis. This is for our Newton-Raphson power flow analysis of bus system for 14 bus system. This is on a voltage and angle for voltage performance we can getting that this IW14 bus system. Now another things on state estimation for voltage and performance. Similar that again with the PMU, without PMU we can find out the two things of this IW14 bus system. This is an entirely focused to the limit demand response. This power we can consider that demand response and improve our voltage stabilization and real power losses we can analysis for the entire system. So this entire codings are will apply that this inbuilt functions to calling the different functions.